Okay, this update is kinda crazy. If you're new here, I'm making a medieval village building game using my own C++ game engine. It's a mix of many of the games I love, together with a ton of novel and weird ideas of my own. And one of those ideas is that I really want my game to be focused a lot on trading. Now, trading itself isn't exactly a new idea in the world of video games, but it so happens that no game I've ever played has implemented it in a way that I envision it. For example, let's take Stronghold. Here, like in many other classic RTS games, you can construct a market building and just use it to buy resources, apparently from air. Or take Civilization 5. You have a certain amount of each resource being continuously produced, and you can sell or buy just one unit of a resource for like 30 turns, and that's it. Oh, and if the AI is mad at you for some made-up reason, it won't sell you its resources unless you give literally everything you have in return, which in most cases is honestly really dumb of them. Or take Mountain Blade Bannerlord. This game actually has a very elaborate economy simulation, and you yourself can play just as a traveling merchant. However, let's face it, this game is not as much about trading as it is about some other activities. Also, it's not a strategy game, and you can't really build anything here. The best you can do is change production in some of your workshops, which in most cases will just make you lose money faster. The games that come the closest to what I'm thinking of are probably Dwarf Fortress and RimWorld. Your settlement actually produces resources, which you can sell individually to pass in caravans, or you can even set up your own caravans and go trading with other settlements. The problem is that it's almost always much easier to be self-sustainable and produce everything you need, and only buy some really rare stuff that you can't obtain otherwise. Now, what do I want from my game? Well, imagine settling in a nice, peaceful, fertile valley. You can grow a ton of things here, but even to get some wood or clay, you have to travel a certain distance. If you don't have a coast or a river nearby, you can't get fish. If you don't have mountains or cliffs, you can't get stone. If your best winemaker wants a golden ring for his wife, he can't just mine and then craft it. The closest ore deposits might be dozens of miles away and you don't even have a pickaxe. Not to mention that you'll need some pack animals to transport the ore, and the whole industry of ore smelting and metal smithing to produce the actual ring. That's the kind of game I want. Is it gonna be way too realistic to the point of being just boring? Honestly, I don't think so. There are many ways to make it work and many corners to cut. Am I asking for too much? Maybe, but you can't really know until you try. And if it doesn't work, I can always at least try to redesign my game around that. After spending several months fighting the existential crisis, that is. Okay, we need other settlements in my game which we could trade with. This is how my game's world looks like right now, and to be honest, it can barely accommodate a single starter village. We need a bigger world, but how much bigger exactly, and how will it even work? You see, there are several ways to make a big world for a strategy game. Take Zeus, for example. Here, the world map is just a drawing. It does have other settlements that you can trade with, but you can't navigate or explore it, and it doesn't really ever change. This is just a static pre-designed map, nothing interesting going on here. It could also be procedurally generated like in Go in Medieval, but it's still static and also rather small. RimWorld has a more interesting option. It has a large-scale map with tons of other settlements, which is split into tiles, each acting as its own playable map. And you can send caravans, attack squads, or even mining expeditions across the map. However, this separation of the world map and individual playable map patches always felt weird to me. I mean, I absolutely get it from the developer's perspective, it makes everything so much easier on the technical level. But wouldn't it be fun if instead of a big world map and smaller separate map patches, we just had the map? Like a whole big world where you can zoom in to see what a single chicken is doing, and then zoom out to see a continent filled with forests and deserts and mountains. Now, there are a few games that do this, most notably Sapiens. This game was brought up in my comments many times, and in fact Dave's devlogs were a huge inspiration for me back in the day. Sapiens is obviously a very different game to what I'm making, but as far as the world map goes, it's probably the closest to what I want to achieve. By the way, if at this point you want to say something about implementing the core gameplay loop first and stuff like that, well, I could probably make a whole separate video about how these game development wisdom cliches aren't really applicable to all genres, and how they absolutely break when you're a hobbyist solo indie developer and your most important resource is not time but motivation, but let's just say I have a bigger plan and I know what I'm doing. Okay, so I want a bigger world, but how much bigger exactly? Well, I took the various time and distance related variables in my game, combined them with my vision of the supposed future gameplay, and figured that something about 100 kilometers across is about right. For reference, that's about the size of Hawaii. Of course, I need to implement a lot of stuff to make this happen, but first of all I need to refactor a bit. You see, right now all my map initialization code is in a single file with about 2000 lines of code, which is pretty terrible. Clearly, things like the list of all tree types or available building materials shouldn't depend on the actual randomly generated map. So I separated map generation code from all the other game initialization stuff, which made the code much easier to navigate, improved compile times, and will be really helpful later for things like saving the game and even for modding. And after that, I started replacing my previous terrain system with a new one. It's not exactly trivial, I can't generate the whole world beforehand now, so I have to work with small chunks of the terrain with various levels of detail that form a hierarchical data structure called a quad tree. This is a pretty typical solution for manipulating large terrains. And of course, the map is generated in background threads so that it doesn't cause lags in the main thread. I was testing all this on a pretty silly map with just a single huge cone in the center, which works great for my case. By the way, it might look smooth, but on the lowest level it's still that grid-based, slightly blocky terrain on a triangular grid. Then I went on to generating an actual procedural map. My approach to map generation is, as always, Perlin noise. More specifically, fractal Perlin noise, with several independent sets of parameters, combined in interesting nonlinear ways to form the resulting terrain. And the result looks like this. There are many noise maps here, one for the overall landmass shape, a few for large and small scale height variations, a few for mountains, and so on. Honestly, I'm pretty happy with how it comes along. And if you like it too, don't forget to like the video and subscribe to the channel so that you don't miss the next devlog. However, there's a small problem. You see this darkening on the grassland? This isn't some lighting issue, but rather it's the outlines. My game uses a custom post-processing outline shader, which darkens pixels based on depth discontinuities. But when looking at a large flat area at a shallow angle, the distances from the neighboring pixels to the camera differ so much that the shader treats them basically as different objects, and darkens them in an attempt to create an outline. This problem always existed in my game, it's just that this huge terrain made it way more obvious. Thankfully, this time I had an idea on how to fix that. It's rather complicated and involves sorting the nearby pixels, using linear regression to reconstruct the plane around the current pixel, and using the furthest neighbors to compute the final outline. It was a bit slow at first, but by using something called sorting networks together with an early out when I'm sure there's no outline, I managed to optimize this shader a lot, and now it is basically free. Okay, let's get back to the new terrain. One thing I wasn't really happy with were the mountains. They're just way too smooth and lumpy. The primary algorithm for generating realistic mountains is called hydraulic erosion, which is basically a brute force simulation of how rain generates water streams that erode the surface. It produces astonishing results, but it is insanely slow and extremely non-local, meaning there is no way I could run it on my whole map. There are noise-based solutions that try to fake the same effect, and I'd love to revisit those at some point, but for now they also look rather slow to me. So instead I just invented my own very simple fractal noise based on stacking random triangular pyramids. The resulting mountains look like this, and I'm more than happy with them. They do look like actual mountain ranges now, which is amazing. Next I had to do another refactor, a much larger one this time. You see, having a large seamless world comes at a cost. The standard single precision floating point numbers simply don't have enough precision at this scale. This is not some made up problem, by the way. If you get to the edge of the map, the grid starts to jitter, the animations go wild, and so on. I could just use double precision for all world space coordinates, but this doesn't really work for me because for rendering entities I need this data on the GPU, and most GPUs don't support double precision. Now, I knew that this problem will come up at some point, and I had the solution already – fixed point numbers. Essentially, I represent the coordinates as a 32-bit integer scaled by some fixed constant, which covers the whole range of 100 km while also providing a uniform sub-millimeter precision across the whole range. So I made a nice generic implementation of fixed point numbers, and then meticulously swapped all world space calculations across all 50,000 lines of code to use the new fixed point format. The result? There's no jitter, everything works smoothly regardless of how large the coordinates are. Then I went on to spawning some actual entities. Nothing crazy, just some grass on, well, grasslands and some trees in the forests. These are only generated on chunks with the highest level of detail. As you can see, the distant trees are rendered just as a single flat mesh, which gets replaced by actual tree entities when you zoom in close enough. It's not perfect, but it works for now. By the way, have I already said how much do I love these trees? Anyway, rendering so many trees takes quite a lot of GPU resources, so I had to optimize that as well. This is where I used a technique called imposters, specifically octahedral imposters. Simply put, it replaces the tree models with pre-rendered images of the trees generated from a bunch of viewing directions. If we add pre-rendered normal and depth maps and interpolate between several of the nearest matching directions, the results are almost indistinguishable from the real model, while the performance is much better. It's not exactly perfect, but there are still things I could do to improve it, and I'm also working on a GPU which is 10 years old, so I'd say this is a success. At this point I kinda got sick of looking at this flat, lifeless sky, so I decided to spend some time on it. In my previous game I actually used a physically based sky model, but it's quite hard to control and to get the exact look that you want. So this time I settled on just interpolating some hard-coded colors for the sky. Then I hacked together a lovely shining sun shader, added randomly flickering stars on the night sky and slapped a textured moon. The moon even has correct phases relative to the sun. It's not like I'm crazy for realism or something, it just took me like a minute to implement. That's an incredible improvement over a flat colored sky, but it still feels a bit empty, so since I'm working on the sky anyway, I decided to add clouds as well. These are actually meshes dynamically generated from some noise maps using a variation of the Martian squares algorithm, and I can easily tweak their speed, density and so on. This is done on the GPU using compute shaders, so this actually works really fast and barely affects performance. I'm not sure of their placement though. They seem way higher than they should be, but if I put them closer to the ground, they will obstruct the view too much. Still no idea what to do with that, so for now I'll just pretend this problem doesn't exist. After all this really important work, I returned to spawning entities. Previously I just hard-coded the randomized placement of grass and oak trees, but my game will have hundreds of different naturally spawning objects, and I can't really hard-code them all. I need a generic system that would allow me to specify some parameters that will control entity spawning. That's what I've been working on next. I made a system that essentially gives me the probability of an entity spawning at a certain spot, based on the terrain, the elevation, the slope and other stuff. Then I filled in all this entity data, populating my forests with random trees and the grasslands with occasional cornflowers and granite boulders. Finally, I had to fix the shadows. This was relatively straightforward, I just used the well-known cascaded shadow maps algorithm, but I think I still need to do some tweaks. I also accidentally added outlines to the faraway forests while debugging something, and I think I like how it looks. It felt out of place at first, but then I added the same for the land-water boundary and it started to look pretty coherent. Still, I don't like that this outline is baked directly into the mesh, and I'm thinking of integrating it somehow into my main outline shader. By the way, if by this point you don't believe that it's the same game I've shown in the previous devlogs, then I won't judge you. But it is in fact the same game, where the villagers can chop down trees, build houses, grow crops and so on. There is still a lot that needs to be done for this huge world update. First of all, I need to do something with water, because right now it is actually just colored sand. I also need climate and biomes, and I've already started working on some weather simulation stuff for my game. At some point I got bored and tried pretending that it's a first-person game and tried just strolling through the forest, and honestly it's way cooler than I expected it to be. It almost feels like traveling through some fantasy lands in a cozy cartoon, which are exactly the vibes I'm going for, so that checks out. I even started considering adding a first-person mode to the game, though I'd need to figure out how exactly that would work. Anyway, that's it for today. Sorry for the long delay between devlogs, but as the saying goes, real life often gets in the way of making YouTube videos. Thanks so much for watching, and I'll see you next time.